students, in this video we are going to solve a problem based on convolution if you consider two continuous time signals. So the statement of problem is like this. Obtain the convolution of x of t, which is u of t, and h of t is 1 for -1 less than equal to t less than equal to 1. So we have to get a y of t with the help of x of t and h of t, where x of t we assume as an input signal and h of t is an impulse response. And we have to obtain the convolution of these two, which will give y of t as x of t convol h of t, which is nothing but an integral having the limit 0 to t decided by the area common between them, and x of tau into h of t minus tau d tau. So what we'll do first we will plot this. X of t is u of t. So this is quite simple. It is having the value 1 from 0 to infinity, and this is like this. It is just having the value from -1 to 1, but the value equal to 1 only. So this is h of t. So for these two signals, we need to find out a convolution. Let's see how we are going to solve. So what we are going to do in the first step, first of all we will replace t by tau, and then one of the signal we will do a time reverse. So since we have used this formula, so we need to do a time reversal of h of tau. So both these operations we do in the same step to get a resultant signal like this. Now, being a symmetric signal, or you can say even signal, even if I do a time reversal, I will get a same signal for h of minus tau. So h of minus tau will be like this. Since this I can consider as placing t equal to 0 to get h of minus tau, meaning I can consider this scenario where we can easily assume there is no shift in the h of minus tau, so t equal to 0. Why we are doing so? Because even if I am not having any shift, still I will get an area common like this, so that we can say y of t equals 0 to 1 is the limit for integral, and that is set by this area, and the magnitude of both this will be equal to 1 only. So such a simple integral we need to solve, so we will get integral answer as tau and limits 0 to 1, so it is 1 minus 0. So in the end I can draw a conclusion y of t I am getting equal to 1 for t equal to 0. Now what we need to do? We need to shift this in the negative side as well as positive side. So in negative side we call as a delay, and in the positive side it is advance. So if I keep on shifting this, what will happen? This area will keep on shrinking, but the fact that you have to keep in mind is that shrinking is dependent upon by what amount we are going to shift. Okay, so I will consider over here t is less than 0. Now if we delay this sequence so that this area will keep on shrinking, one instant will appear where that area becomes 0, and that instant is nothing but tau equal to 0, and that will happen if I'm having the shift equal to -1. Why -1? Because minus is a delay, and if I shift this by 1, this end will come over here, and beyond this shift there won't be any area common. So now while shifting to the negative side, there is a restriction up to 0 only, so that now I can say the shift I've selected such a way that I will get this figure. And h of minus tau is shifted by some amount t, so that we will get an area like this. This is h of t minus tau, where t is less than 0, and over here, since the limits over here -1 and 1, that will get modified to -1 plus t to 1 plus t. Now we need to be careful. As I said earlier, this areas keep on shrinking, and at one instant this will be 0. That means there is no overlapping, and that will happen if this line will coincide with this, meaning for the shift which is -1. So what we need to do over here, t has to be greater than -1, but it should be less than 0. So in this limit I will get this characteristic, and this characteristic, how it is different than the previous case? In this we are having the limits 0 to 1 plus t, and if you solve you'll get an integral tau, limits are 0 to 1 plus t. So if you solve, we'll get 1 plus t minus 0, which is 1 plus t only. So now I can draw a conclusion. Y of t is 1 plus t for t in the range of -1 to 0. Now suppose t is less than -1, so that I will get a signal structure like this. What I said, t is less than -1. If I consider t less than -1, the h of t minus tau will be like this. this is -1 plus t, this is 1 plus t, and this signal is h of t minus tau. So if the t is less than -1, what I can get? No overlapping between these two signals, hence I can say no area common, so y of t will be 0. So let me write it properly. So I can say no area is common between x of tau and h of t minus tau for t less than -1, hence y of t equal to 0 for t less than -1. And that will be the case for any value of t which is less than -1. Now we have to consider a t greater than 0. So in this case we have to consider t greater than 0. So see how I am getting. So t greater than 0 will result into a signal plot like this. So this is -1 plus t, this is 1 plus t, and the area which is common will be like this. This signal that we got is h of t minus tau. Now here there is an area common and the area having a limit 0 to 1 plus t. So I can say y of t integral from 0 to 1 plus t 1 into 1 d tau equals tau is the integral value and limits 0 to 1 plus t, which is nothing but 1 plus t minus 0. So in the end that will be 1 plus t only. So I can say y of t is 1 plus t. Now we need to check up to what extent this will be continuing, because what will happen if I keep on increasing the value of t, the area is keep on increasing, and at one particular instant the entire sequence will be inside this x of tau, and that range of tau we need to find out using the t. So what will happen, this will keep on shifting over here till the time this line coincides with this 0, and that will happen for t equal to 1. So what I can say over here, this particular phenomena we are getting only when t is greater than 0 but less than 1, because what will happen, beyond t equal to 1 I can get some different structure that we need to find out shortly. So what I will get, y of t is equal to 1 plus t for the range 0 less than t less than 1. So we'll get one more output. Now let's go to the next. Now what I said, this line crosses 0. We need to check how the signal will look like. So what is happening over here now? The entire signal is inside this x of tau. This is minus 1 plus t, this is 1 plus t. So now the integral will be y of t equals, limits are from minus 1 plus t to 1 plus t, values are 1 into 1. If we simplify, we will get tau as the integral, limits are minus 1 plus t and over here 1 plus t. So if we simplify, we will get 1 plus t minus 1 plus t. So after solving, we will get 1 plus t plus 1 minus t. T get cancelled, 1 get added. So in the end, I will get y of t as 1 plus 1, which is 2. Now comes the important point. Up to what extent this will be continued? You take t equal to 2, t equal to 3, t equal to 4. Every time this is just keep on shifting, because there is no limit for this x of tau, which is up to infinity. Hence I can say now this t is greater than 1 and that will remain forever. So let it be t of any value which is greater than 1. Every time we will get this integral. So here we can stop and we can say y of t is equal to 2 for t greater than 1. So what we have done till now is that after any shift which is more than 1, every time y of t will going to remain fixed and that is equal to 2. So let's club all the results so that we can plot the y of t. So y of t we are getting as 1 plus t in the range for minus 1 less than t less than 0. Then we got y of t equals 1 for t equal to 0. Then we get y of t as 1 plus t once again in the range of 0 to 1, and then beyond 1 I'm getting y of t equal to 2. So let's plot this signal now. So here we are having the limits minus 1, 0, then 1 like this. So what happened during minus 1 to 0, it is 1 plus t. So how to get a, simply you put t equal to minus 1 over here so that it will be 0. So for minus 1 the signal will have the value 0 and for 0 it will have the value 1. So somewhere here we will have the value 1. So what we are getting over here is a straight line, because this is the equation of a straight line. So joining these 2 points we will get a line like this. Then at t equal to 0 you should get y equal to 1, which is we are getting already. Then from 0 to 1 it is once again 1 plus t, meaning what? Same line we need to continue till t equal to 1. So t equal to 1, same line if you continue, in the end it is going to meet somewhere here where the y will obtain the value 2. So we will get a line like this. And then what is happening? Beyond 1 it is remaining constant equal to 2. So this will be the plot we will get for y of t, which is nothing but a result for convolution of x of t and h of t given. This is the end of a problem. Thank you.